Secure your Elixir apps with Paraxial IO. From code analysis and bot defense to dependency checks, they've got you covered. Elixir first design with GitHub integration. Elevate your security at Paraxial.io. All right, what's up, everyone? Today is the final video, or the final section for our anti-patterns, the Elixir anti-patterns guides, but it should be a good one. I was like a little hesitant with starting this one too soon. I almost considered doing the meta programming section before this one, but I think I can, high level explain things if you're not too familiar with how macros work. But yeah, I think we'll have a lot of fun still. So let's go ahead and jump in. I'll share my screen. And I see what's going on. I'm going to just hide that chat window. All right, let's open up Safari and go to elixirlang.org and jump over to guides. And then on the left side here, we're going to scroll down to the anti-patterns section and then select metaprogramming anti-patterns. And I'll shrink that tool sidebar and make this a little bigger. All right, that should be good. Sweet. All right, so let's go ahead and just jump right in. Metaprogramming anti-patterns. This document outlines potential anti-patterns related to metaprogramming. Okay, so large code generation. Problem. This anti-pattern is related to macros that generate too much code. When a macro generates a large amount of code, it impacts how the compiler and/or the runtime work. The reason for this is that Elixir may have to expand, compile, and execute the code multiple times, which make compilation slower and the resulting compiled artifacts larger. So the example here, imagine you are defining a router for a web application where you could have macros like get arity2 on every invocation of the macro, which could be hundreds. The code inside get arity2 will be expanded and compiled, which can generate a large volume of code overall. All right, so let's go ahead and look at this. All right, so we have our routes module, and then we are creating a macro inside of this. Okay. And if you're not familiar with macros, I guess we should talk about abstract syntax trees. So a macro will always take an AST, which is an abstract syntax tree, and return an AST. And so whenever you see this quote block, everything inside of it is going to be returned as an AST. And I'm trying to think, maybe the best way, let me just show you what an AST looks like. So if I make this a little bigger, is that big enough? That should be big enough. Okay, let's just start an IEX shell here. And if I go ahead and just do a quote do here, and I'm just going to do a 1 plus 2, just a very simple addition arithmetic in a quote block, okay? When I hit enter, we're going to get an AST representation back of 1 plus 2. And so this is what quote is doing to our Elixir code. So basically inside of a quote block, it allows us to write Elixir code the way we can read it and understand it. But then it is returning an AST, so abstract syntax tree representation of the code we just wrote. So what we're seeing here is the first element is an atom, and that is denoting a function, or it could be another tuple representing a nested node. So in this case, we did 1 plus 2, so it is calling the addition function. And then the second element here is just metadata about the expression. So you can see that the context is Elixir, and it's importing a function from the kernel. And yeah, that's metadata, like high level. And then the third one is the arguments to be used for the function call. And so we have a list of two numbers, 1 and 2, and that's our 1 and 2. So that is an AST. You can have nested ASTs as well. So like if we did quote do, I don't know, if we did like 2 times 3 plus 2 and hit enter, you're going to see we have like our tuple is still returned, but as arguments for the addition, so it's order of operations. We're doing our multiplication first, right? So in here, you see the normal, the 2 times 3. So we're calling our multiplication function here, and we're passing in 2 and 3 as arguments. And then this is inside, this is the first argument in our addition one. So it's harder to read, obviously, but they're just nested in here. So the more complicated the code gets, it will just be nested in the order of operations. So high level, that's what an AST is. And let's continue with this guide, right? All right, so we have our macro get, and let's see, we're passing in a route and a handler. And let's see, we are, unquote is another good one that we should talk about. Basically, it allows us to inject any value that is outside of the quote block context. So it gives us access to route because route is outside of the quote block here. So unquote allows us to essentially inject route here. Same thing with handler. We're just injecting the value here. All right. I think that's good enough. So let's see, that's what we're doing. And so we're unquoting, or we're injecting our route and handler and then setting them to new variables so we have access to them. And then we're checking if it's not a binary, we're returning an error. If it's not an atom, we're returning an error. And then other than that, then we're storing the route for compilation. All right. So what are they? Okay, yeah, so they're saying that we are potentially generating a large volume of code depending on how many connections. Sorry guys, I forgot what the example was. Imagine you are defining a router for a web application where you could have macros like get arity2 on every invocation of the macro. Okay, yeah, so this could generate a large amount of code. That makes sense. And then so refactoring, to remove this anti-pattern, the developer should simplify the macro. And delegating part of its work to other functions as shown below by encapsulating the code inside the quote arity1 function. We have our, instead of defining functions inside the quote block here, we can put it in the define arity3, which will reduce the code that is expanded and compiled on every invocation of the macro. And instead, we dispatch to a function to do the bulk of the work. Okay, so in this case, we are using the define arity3 function here, and instead of this being generated for every instance or connection to our app, this will exist in one place and can be reused over and over for every time this macro is used. So that makes sense, right? I feel like I'm kind of regretting doing this section before, what is this? The meta programming. That's all right. We'll see. We'll go through it. It's not very long. I feel like if we get lost we'll come back, or we'll go and do the metaprogramming section in the next live view or the next live stream, and we'll go from there. But basically, macros are compiled at compile time, and this is avoiding rewriting of code, right? All right, so unnecessary macros. Problem. Now, I think this is probably the bigger version. If you've read, I highly recommend Chris McCord's book, Metaprogramming. He has a quote in there that says, not to use macros I'm obviously butchering it, but basically don't write a macro unless you absolutely have a big need to write one, right? So unnecessary macros. Problem. Macros are powerful meta programming mechanisms that can be used in Elixir to extend the language. While using macros is not an anti-pattern in itself, this metaprogramming mechanism should only be used when absolutely necessary. Whenever a macro is used, but it would have been possible to solve the same problem using functions or other existing Elixir structures, the code becomes unnecessarily more complex and less readable. Yeah, don't write a macro if you don't have to, because I have a hard time every time I write macros or try to dig through and debug macros. It's one of the hardest things. Like it just doesn't, they're hard to read. And I feel like they're even harder to read if you didn't write them. So it makes sense. Don't use them where you don't need them. Whenever a macro, sorry guys, I lost my place, more or less readable, because macros are more difficult to implement and reason about. Their indiscriminate use can compromise the evolution of a system, reducing its maintainability. Yes, I agree 1,000% with that one. So here's an example. We have the myMath module. It implements sumArity2 macro to perform the sum of two numbers received as parameters. While this code has no syntax errors and can be executed correctly to get the desired results, it is unnecessarily more complex by implementing this function as a macro rather than a conventional function. The code becomes less clear. All right, so we have our myMath module, and then we're defining a macro here called sum. It takes two arguments, v1 and v2. And then since a macro always has to return an AST, it needs to be in a quote do block here. And then for us to get outside access to v1 and v2, because it's out of the context of quote, we need to use unquote. And then below, we have an IEX shell here, and we're using require. So require gives us access to macros within our module. I believe require gives you access to all macros in a module. Use gives you access to all macros and functions. And I can't remember what, maybe import is both as well. This is quizzing my memory too much. But and then alias will only give you access to the functions in a module. So we're requiring myMath, okay? And now we have access to the sum macro here. So math.sum, and it's used just like a function in this case. We're passing in 3 and 5, and we get 8 back. And then here we're just passing in a 4 and an 11, and we get 15 back. So it works just like a normal function would work, but obviously I think we're overcomplicating things here, just because I think the second you start returning ASTs and using unquote and quote, it's already less readable to most people. So refactoring, to remove this anti-pattern, the developer must replace the unnecessary macro with structures that are simpler to write and understand, such as named functions. The code shown below is the result of the refactoring of the previous example. Basically, the sumArity2 macro has been transformed into a conventional named function. Note that the require arity2 call is no longer needed. Okay, so instead of doing def macro, we just created a sum function here, and it's still taking our two arguments, and then all we're doing is adding them together. And then in our IX shell, we no longer have to require my math because we can just call our module.sum and have access to that function. And then it works the same way. So 3 plus 5 is 8 and 4 plus 11 is 15. All right. Use instead of import. Oh, good. I didn't remember what import did. And now we can remember. All right. So use instead of import. The problem, Elixir has mechanisms such as import, alias, and use to establish dependencies between modules. Code implemented with these mechanisms does not characterize a smell by itself. However, while import and alias directives have lexical scope and only facilitate a module calling functions of another, the use directive has a broader scope, which can be problematic. The use directive allows a module to inject any type of code into another, including propagating dependencies. Yeah, so you want to be very cautious when you're using use in your project, especially with third-party dependencies, right? Because they're basically what you're doing is all the code they wrote, you're injecting it straight into your module. So whatever they write and whatever third parties or whatever they're doing, if you don't understand completely what that library is doing, it could be a huge security vulnerability, right? You're injecting their code straight into yours. Including, propagating dependencies. So yeah, they could use, unsecure dependencies. Who knows? This way, using the use directive makes code harder to read because to understand exactly what will happen when it references a module, it is necessary to have knowledge of the internal details of the referenced module. Yes, that makes sense. If you don't know everything that module is doing, you're just adding possibly dangerous code into your code base. All right, so example, the code shown below is an example of this anti-pattern. It defines 3 modules, module A, library, and client app. Client app is reusing code from the library via the use directive, but is unaware of its internal details. This makes it harder for the author of the client app to visualize which modules and functionality are now available within its module. To make matters worse, library also imports module A, which defines a foo-arity0 function that conflicts with a local function defined in client app. All right, let's try to wrap our heads around all this. All right, we have a module A. We have a function called foo. All right, and then we have a library module here that is overriding using. So whenever you are using this is when you would have to use the use. That's when you have to use to use that macro, right? Or that module, that macro, I'll call it. All right, so this macro is importing library and module A. So this is an example of just propagating dependencies that we don't really know about being the client app, right? And then let's see, then we have a function here called from library. Okay, I see. So then our client app down here is blindly, we're using the library macro and we're using the use case and that calls this using, right? And we're automatically importing module A. And inside the client app, we also have a function called foo. And module A has a function called foo as well. So that is a function conflict right there. And then we have another function called from client app. And it looks like we call, so from lib, and then we concatenate the string and then call foo. Yeah, I'm kind of tempted to write this out. This would be kind of fun and then so when you compile the client app, Elixir detects the conflict and throws the following error. Okay, so the compiler does catch it. It says an error. So imported module a.foo conflicts with local function client app line .ex line 4. So you we have no idea what module A is, right? That is our dependency coming from a macro we're using. And now we have a conflict. So obviously, like if you wanted to keep using this and you trust this macro, you would have to rename your function here. But let's see, they're refactoring. To remove this anti-pattern, we recommend library authors avoid providing the using arity1 callbacks whenever it can be replaced by alias or import. So yeah, don't use using if you can avoid using it. In the following code, we assume use library is no longer available and client app was refactored in this way. And with that, the code is clearer and the conflict as previously shown no longer exists. So now we're importing library. Let's see. To remove this pattern in the following code, we assume use library is no longer available. Okay, so that means this got removed. And now we're just importing the library, which gives us access to our from library function. Yeah. Okay. And then now we can call our from client, and our foo function now calls the local function in our client app module. All right. Now I know, actually they might cover it. Okay, yeah, they're gonna talk about gen server here. So additional remarks: in situations where you need to do more than importing and aliasing modules, providing the use module may be necessary, as it provides a common extension point within the Elixir ecosystem. Therefore, sorry if you guys can hear that, there's a weed whacker outside of my window. Therefore, to provide guidance and clarity, we recommend library authors to include an admonition block in their module doc that explains how use my module impacts the developer's code. As an example, the gen server documentation outlines. So use gen server. When you use gen server, the gen server module will set a behavior gen server. So we're using a gen server behavior and define a child spec function. So your module can be used as a child in a supervision tree. Think of this summary as a nutrition facts label for code generation. Make sure to only list changes made to the public API of the module. For example, if use library sets an internal attribute called @SomeModuleInfo, and this attribute is never meant to be public, avoid documenting it in the nutrition facts. That makes sense. So only the user-facing things of your macro you should document in what is that? Your admonition block. All right. For convenience, the markup notation to generate the admonition block above is this. So we have some 4 hashtags and then the use gen server and our info. So when you use gen server, the gen server module will set a behavior of gen server. So we're inheriting the gen server behavior and define a child spec function so your module can be used as a child in a supervision tree. All right. I think that makes a lot of sense. I feel like there's a lot to unpack here, and I didn't want to do the metaprogramming section next, but I feel like this video or this section is forcing my hands. So what we'll do is we'll plan on doing the metaprogramming sections next week. I think that'll be good. And I think that'll make this anti-pattern section make a little more sense. And if you want to dive deeper into metaprogramming and like DSLs and things, my Elixir a comprehensive introduction course on indiecourses.com is available, and I have a whole section on metaprogramming. I should say it's a in-depth beginner module though. Like it doesn't go too deep, but we touch on creating macros, and then we make our own DSL, which is really cool. And then we learn how to test our DSLs. And so it's a really cool, worthwhile section. So if you want to learn a little more than what is in the guides here, I highly suggest checking out my course at indiecourses.com. And thank you guys for tuning in. This was a fun section, and sorry if a lot of the metaprogramming stuff was over your head, but I think we're going to hit the metaprogramming guide in the next section. And let's see, Daniel, I don't know why that's not showing up, but oh, there it is. What's up, man? Good to see you. I'm excited. I'm going to be having do I say a Daniel or Daniel? I don't know. But anyways, he's going to be joining me on the Elixir Mentor podcast. I'm super stoked. It's going to be a fun chat, because that is, I believe, embedded analytics. Sorry if I got that wrong, because I talk to way too many people now. I think that is. Oh man, my brain. I'm excited though. I had to go. I'm checking out Elixir Mentor events. Yes, embedded. Look at that. My brain, I'm on, even though I'm not sure. But I'm excited to chat with you about your projects and all of that. But all right, guys, thank you so much for tuning in. I will see you guys in the next live stream. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. See you guys.